Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Welcome to BCM 3203 Computer Game Programming 2 with me, Dr. Sarah. Okay. For this video, I will go for the next module, which is in the chapter 3, Game Physics. And before that, let me make some clarification. This video is made for my students who enroll the subject, or maybe everyone that want to learn about the game programming, the basic computer game programming. Okay, so in this video, I will cover only the content of the 3D maps for games. The rest will be covered in the next video. So without further ado, let's move on to the topics. In a modern 3D games, as you can see from the existing game, actually it is made up of a three-dimensional objects in a virtual world, where this mathematical model of the virtual world was simulated in a real time on a computer. And for your information, mathematics basically pervades everything we do in the game industry. And the game programmer, you yourself, will make use of the virtually all branches of mathematics, starting from the trigonometry, algebra, statistics to calculus. The more mathematics theory you know, the more easier you can solve the problem and during programming the game. And basically, the most prevalent kind of mathematics that you will be doing as a game programmer is 3D vector and matrix maths. For example, the linear algebra. By understanding this 3D vector concept or the theory itself, it will help you a lot in understanding the environment you work with, the movement you want to make, and also the space that you work. Also, besides that, by understanding how to implement the 3D maths inside the game development, you will help yourself to identify how to manipulate the game object inside the space. For example, if you want the character to move forward and backward, what are the parameters that you need to change? You want to make the object jump on the space or jumping on the plane. So what are the things that you have to change to make it jump upward, not downward? The same thing if you want to implement the projectile. So what is the mathematical implement for the projectile itself? Okay. And this is why I said that kind of mathematics used in programming the 3D. For example, like geometry is very important to describe the 3D and 2D worlds. Do you still remember the geometry topics that you have learned during your school term? Yeah, I hope so. I hope you can still give what is the geometry out of your understanding from your class before, from your previous school. And the next one is trigonometric functions. Who love trigonometric function? Before this, you see the trigonometry as mathematics on a paper and the mathematics as it is. But inside a games, actually, these trigonometric functions are very great to be used for special effects and making things act organically. And the next one is the twin functions. Do you remember what is a twin function? Maybe you can go Google it and find out what is the twin functions. These twin functions are very handy to express the movement over a constant time. And as I mentioned earlier, the more maths you know, the more tools you have to solve any problem that come up when you program a game. Alright, so for your information, a game engine needs to keep track of the position, the orientation and the scale of this object. And then from that, they will animate them in the game world and then transform them into the screen space so that they can be rendered on the screen. Student, do you still remember what is a game engine? Yes, for example like Unity. When you use Unity as your main game engine, you have to understand what is the space that it uses inside the game engine. You want to work on in the 2D or in the 3 dimensions, so you have to identify that thing. So by having that one, these game engines will keep track on each position you give to your game objects. If you give the value wrongly, so the game engine will render everything that you give into the scene. So don't blame the game engine if your games didn't turn out to be what you want, but recheck all the coordinates, all the position, all the programming that you do. Maybe you want them to move forward in the Z direction, but unfortunately the programming or the value of the coordinates you are not doing in that way. The same thing happens especially when you are trying to do someone code that already existed in the website. So you want to implement the same thing, the same movement. You just copy paste into your game engine, but you may make some mistake. Suddenly you realize why the example shows the game is moving forward, but when you copy paste everything inside your Microsoft Visual and give the same thing, the same instruction to your object in the Unity, but your object moves backward. Do you think about it? So start with checking the coordinate you use for your system. It might be different compared to the coordinate used in other example. And then, in games, almost all 3D objects are always made up of triangles, which the vertices of which are represented by point. So this is where we want to look at what is point. So, what is point? How do you understand by the definition of point? What is it? Can you illustrate a point inside your space? Okay, I believe everyone already know what is point because you already worked with a 2D dimension. It's not that far different to the 2D. Besides, in fact, the points in a 3D dimension encompass the x, y, z. For example, like this. P is a point in which the location is the x, y, and z. And this point is identified by the Cartesian coordinates that you use in your system. Okay, in your game development. Okay, last time in the previous semester you already learned about the Cartesian coordinate in XY. To be able to develop a 2D game, it is very important to know the Cartesian coordinate well. So you have already used the XY in the 2D game. This semester we will focus more on the 3D part, which is it has the X, the Y, and Z. So you have to determine which one is the right, left, and which one is the front, backward, and which one is the up and down. Can you? Never mind, we will take a look at this later. The next one is about beside Cartesian coordinates, we also have other common coordinate systems such as the cylindrical coordinates and the spherical coordinates. And always remember to select the coordinate system that best maps to the problems at your hand. What I say is the most prominent, the most basic, the most regular coordinates we use is the Cartesian coordinate system. But in a different situation, based on the problem that you have in your hand, you can also try to implement the cylindrical and the spherical coordinates. Right, remember what I asked you earlier regarding the how you want to identify either it is forward, backward, downward, upward, or left and right. So here where the implementation of left-handed and right-handed coordinate system. It is still the three-dimensional Cartesian coordinates, but you have two choice of rearrange the game object inside your scene, inside your space. But please bear in mind, the rules of the mathematics do not change between this system coordinate. Regardless whether you use the left hand or the right hand, the rules of mathematics remain. But what's changed? What do you think changed in this system? Yes, the interpretation of the numbers. Our mental image of how these numbers are mapped into the 3D space is changes. For example, when you use the right hand and the left hand, you can see that the index fingers pointing different way. So that's why I say the mental image, how you visualize the numbers inside your punya space will be changed. For example, like this one. For right-handed, maybe the Z is pointing forward. But for the left-handed, the Z is pointing far away from the viewer, backward. Right, that is about the left-handed and the right-handed. Okay, before that, let's take a look at the unity. Okay, let's see in the unity space itself. This is your 3D space, what it looks like. And when I choose to the main camera, as you can see, the main camera has the XYZ location. So this is our space. You have to really understand on how the coordinate is working. As you can see here, can you see this one? Okay. When you can see the environment or the Cartesian coordinates used inside the inside in the unity is something like this. The camera is positioned so that it will project the view in the Z direction. So this is the X and this is the Y. So the backward direction is the camera looking at. And the projection can be either in terms of the perspective. Kalau tengok, perspective is something like this. This is what we basically do. Or you may change the projection into the orthographic. So this is what's going on. For the orthographic, so to work in whatever perspective or the projection, either perspective or vertical, is up on what kind of game you want to develop. So always remember, if you work on this position, which is the XY, and you want the camera to look at it, so whenever you want to make a point, make sure that the point is inside the camera, and then you give the direction on the x, y, or the z direction. So basically in Unity, the main camera determines the game view. So you have to select either you want to make it as in orthographic, where the space represented in a large cuboid, or you want to do it in a perspective, which is like a frustum. Can you? Okay, so the next part is the vectors. What can you understand about vectors? Do you still remember what is a vectors? Yes, a vector is a quantity that has both a magnitude and a direction in the n-dimensional space. So again, when you work in a 2D space, so the magnitude and the direction will be in the x or y axis. But when you work in the 3D dimensional space, the direction might be in the z direction. So you have to know either it is a positive direction or negative direction. Basically in game, vectors is used to move a character. So when you want to move a character, you use these vectors. Give a value to this character, and if you identify the vector's value as positive, so it will move forward. If you make it as a positive z, it will move forward, and if positive x, it will move on the right side, and so on. This is how you implement the vectors in the game. Okay, there are differences between points and vectors. I hope you can identify or you can differentiate what is point, what is vectors. There might be cousins between them, but they have the distinction, so that you can differentiate between what is a point and what is the vectors. And majority of the game programmers will use the term vectors to refer both to points, which is the position vectors, and to vectors in the strict linear algebra sense, purely in directional vectors. Okay. Basically, this is kind of question that need the answer in vectors. So, can you answer this question? Okay, so what is the answer? Okay. Okay, other than that, vectors can always be used to calculate the distance. Why? Because it is very important to determine where the objects are in the environments, and then you calculate the angle and normalizing the vectors, and this calculating the distance can be used when trying to determine where is the enemy and their range and where are the other resources. So, how do you think giving one direction vectors, let's say you have this point A and this point B, how will you calculate the length? Right, this is where you use the theorem Pythagoras to get the hypotenuse. This is hypotenuse. If you give the xyz, so you can get the hypotenuse, which is the length from direction A to direction B. Do you still remember, isn't it? I don't have to teach you back with the basic mathematics, right? Okay, so the next one is about the equality. The vectors are considered equal if all the members' value x, y, z are equal. So basically, vector didn't have a position. They are just a direction. So as long as it goes to the same direction, so it will consider as the same vector. The next one is by using the vectors addition, you can increase. For example, like previously I said that vector didn't have any position, so it can be position starting from the starting point 0, 0, or maybe for like this example still use the direction. So by adding the vector A and the vector B, you get this vector. Okay, and basically you are added the vectors together when trying to get a certain offset in the 3D space. This is what we do in the games. Basically, especially for example, you want to put this hollow on this top of the human. So you already know the direction of the hollow and the direction of the human, of the player. So what you can do is you add the vectors of this player with the vector of this hollow. So the result, it will get the hollow vectors on top of the head vectors. So you can see like the character is hovering with a hovering halo. And if you can use for addition, you can also use for the subtraction. So for the vector subtraction, for example, you want to do a spaceship in which you know the spaceship is in the A vectors and the spaceship of the vectors of the missiles is the B. So you want to make the direction of the spaceship to the missile, for example, so you can make A minus B, so it will hit by. So the vector direction will be depend on either it's move forward or backward. And the next one is about the magnitude. Magnitude basically is the length of the vector that can be measured in the 2D space. So like I said, you can use the Pythagorean theorem Pythagoras to calculate the vector's magnitude, the calculating the instant. And then the next one is multiplication. For example, like you can multiply a single vector to make it as a largest vectors. For example, we have two similar vectors, so when you multiply by 2, you get a longest vectors. But the direction will not unchanged. What changes is the vector's value. So the vector's values will be double. And the next one is multiplying. You can multiplying the vectors by 2 to length the vectors, and if when you multiplying by -1, you make it backward. So if you want to change the vector direction, you can multiplying the vectors with -1, so it will give the different direction. If you multiply with a large number, then the vector will be large. For example, like this one. In the game, when you want to give the effect of a character being shot by a bullet. So let's say this is the bullet. You take the vector of the bullet and then you move it backward, reverse the vector. So the vector now will point outward from the body along the line. Then by having this perfect vector, you can make a blood splat effect. And then you also have the normal vector. Normal vector is when the vector is perpendicular to that surface, and is very highly useful in games and computer graphics, in which a plane can be defined by a point and a normal vector. But remember, normalized vector is not a normal vectors. Okay, theory here, and then again another theory about the normalized vector. I really hope you still know. If not, please revise back your knowledge on mathematics for the computer graphics. How about normalization? What is the difference between normal vectors and normalized vector? Okay, so the next one is, this is the activities can be done. So answer this kind of question. If you can answer this question, then you can differentiate between the magnitude and the direction. Okay, how much do you weigh? So your weight is a scalar quantity, but the force of gravity which pulls you downward is a vector. So you know how to differentiate the vector quantity and the scalar quantity. Alright, I think that's it for this video. We will take a look at the example in the next video before we proceed with the matrices. Okay, with that, I end here. Thank you very much and see you guys again in the next video. Thank you.